So in this example, we want to construct, or we're asked to construct a non-zero 3 by 3 matrix A such that 2, 1, negative 3 is a solution to the homogeneous equation AX equals 0. First of all, non-zero 3 by 3 matrix, so that just means when we say it's a non-zero matrix, we mean it's not a 3 by 3 matrix with zeros in every entry. So that's what when we talk about a zero matrix, it would be a matrix whose entries are all zeros, like when we talk about a zero vector. So if there's any entry if there's any entry that's not zero, then that's a non-zero matrix. I just want to be clear. It's not to say that every entry must be non-zero. It's that not every single entry is zero. If that's okay. The trick to a question like this, not trick, but the key here is the way that you think about the product A times X. So remember that the way to write out this matrix times a vector product is to think about the entries of this vector X times each of the columns of A. So if we write this product A times X as, okay, so we've got column 1, which I'm going to represent as A1. And then column 2 will represent that as A2. And then column 3, I'm going to represent that as this vector A3. So pretend like A1, A2, A3 are these three-dimensional column vectors here. And we're multiplying that times the vector x, which the problem is telling us that we want x to equal 2, 1, negative 3. So we're supposed to find a matrix where this is equal to the 0 vector. Okay, now again, actually I think I just want to write this as the 0 vector here, like that. Okay, so matrix times a vector. We do first entry, 2, times the first column of A, second entry, which is 1, times the second column of A, and then third entry, so negative 3, times the third column of A. So that gives us this equation. So what we need to do is build a 3 by 3 matrix with columns A1, A2, A3 so that A1, A2, A3 satisfies this equation. So as an example, let's say that A1 is all ones, 1, 1, 1. And A2 is also all ones, 1, 1, 1. Then notice that, so 2 times A1 would be 2, 2, 2, right? Plus A2, which is 1, 1, 1. And then minus, if we do 3 times 1, 1, 1 here, then that would be, 3 times that. So minus 3 times that. So this would be 3, 3, 3. Then wouldn't that be, so that'd be 3 minus 3, 3 minus 3, 3 minus 3. Yep, this would work. So 3 by 3 matrix with all ones. That's one way to make this work. So this part of the solution, this is guess and test, and there are infinitely many correct answers, just to be clear. You could play around with this. So you could say, okay, let me make column 1, 2, 2, 2. And let's see, so that's going to give me all 4s here, right? If I make this, I'm going to end up with just 2 times everything. Yeah, but like I said, you can kind of play around with it, or I could do 2, 1, 2. I don't know why you would. I'm just kind of making things harder on myself. But I think if we did 2, 1, 2, let's see, because that would give me 4 plus 2 is 6. And so if I do 2 here, that'd be minus 6. So that'd be 0. And then 2 times 1, so that'd be 2 plus 1 is 3, minus 3 times 1, so that'd be 0. Okay, so here's another way to make it work. But the key in these problems, because you'll have one like this in your homework, is to write your A times X as, so whatever vector X you're given, first entry times first column of A, second entry times second column of A, third entry times third column of A. And then you just set up columns that satisfy this equation. So now you can just make something up. And like I said, there are infinitely many correct answers.